Hello, and welcome to the GSSI Training Academy's ongoing series on the PaveScan RDM 2.0. My name is Jake, and I'm a technical trainer here at GSSI. And today, I'm going to show you how to generate a mixed calibration file from cores you've collected in the field, and how to attach that mixed calibration file to a project name. The reason why you would want to generate a mixed calibration file and attach it to a project name is so you could view all of your data as percent compaction or percent void content for that project name. Otherwise, you'll only be able to see your data as a dielectric value. So to start off this process of generating a mixed cal from our cores, we're going to start by tapping the playback button, and then we're going to tap playback file. Next, we're going to select the project group and the name that the mixed calibration will apply to. Now remember, whenever the mix for your project changes, you will want to create a new project name and attach the new mix calibration to that new project. So after you've selected the project group and project name, you're going to tap the project info button. Then you're going to tap the other info button here located along the bottom. Lastly, we're going to tap on core measurements. Right. Now, when we scan cores in the field by using the measurement type core, it saves a core file to the project name. All of the cores that we have scanned and saved under project name can now be viewed here. In this screen, we can see all the information for each of our core files, including core file name, the station number where each core is collected, and the dielectric value for each core. Now, we're going to tap on the Generate Mix Cal button. Now, first, we're going to need to enter a name for the mix calibration file, and then we're going to need to hit Save. Otherwise, if we do not provide a mix calibration file name and hit Save, we're going to get this error notice that pops up that says, please save new calibration before calculating for measurements. So I'm just going to give mine the name Day 1C. Right? Whatever naming convention you have, use it. I'm not demonstrating a naming convention here. This just happens to be what I'm naming my file. All right. Now I'm going to hit Save. And as you notice, the Calculate for Measurements button at the bottom of the menu is now active. So now we can select the mix measurement type from the drop-down menu. So in this case, the mix measurement type would be whatever value the lab has provided you with for each of your cores. So when they run tests on your cores, they could provide you with a mix measurement type of percent voids or percent compaction or the density of your cores. So you're going to select the value type that corresponds best with what the lab has provided you with. I will note that percent void and percent compaction are the easiest values to enter and are thus recommended for this system. Now, if you are using GSSI's MDM system, you will use percent voids as your measurement type category. And again, if you do not have an MDM system, you can use whichever value the lab has given you for your course. Okay. So now we are going to tap on the Calculate for Measurement at the bottom of the menu. Okay. Now, here you will see all the cores you collected in their dielectric values. So here we can enter the percent void or the percent compaction value, whatever the lab has given us, for each core that we've collected, right? Now, we're not going to enter in a value for the dielectric deviation. Another note here, we can click the checkbox Include in Calculation for each core we wish to include in our calculations. And we can click Calculate GMM Dielectric at the bottom of the menu once we have entered in this case, our percent void content for all the cores that we want to include in our measurements. So I am just going to enter in a few values here for percent voids. Okay. So let's say that these are the values I got back from the lab. Okay. Now, let's say I only have values for 3 cores for whatever reason. Obviously, I would, if I sent all of these cores to lab, I would have values for each one. But just to speed up this process, I'm not going to enter in all of the core values. So what I'm going to do is I am only going to include these first 3 cores in my core measurements, and I'm going to uninclude in my calculations these additional cores. All right. Now I can click on this Calculate GMM Dielectric button here at the bottom. Right? Let's try it out. Now I'm given a calculated value. My GMM dielectric is given at 5.821, my standard deviation at 0.056. Okay, so now I can click OK to accept this calculated value. I can hit save now. And now I have my mixed calibration file name. I now have a value for my GMM dielectric, whereas before it was 0. I have a value for my standard deviation, whereas before it was also 0. I'm going to leave my GMM at 0 as well. All right. Now, at this point, I'm going to hit save, and I have successfully generated a mixed calibration file from my cores. All right. So what the system really needed was a GMM dielectric value that was created when I took the dielectrics of my cores and I added the percent void content for each of my cores. It was able to generate this value from all the cores that I included in my measurements. All right. So at this point, I can return to playback. Okay. And I can select a project name that I want to apply the mixed calibration to. And I can select the asphalt mix calibration file from the drop-down menu. So in this case, I'm going to go to Project Info, and I'm going to select a mix calibration. I believe I named it Day 1C. I can now hit Save. All right. So now when I view my selected data, my selected file in playback mode, I can now choose to display the data as percent compaction or percent void content, or I can still see it as dielectric, all right? So because I successfully created an asphalt mix calibration file from my cores, I'm now able to see my data as percent compaction and percent void content, which is more helpful than just seeing my values as percent dielectric. Any questions? You can email us at training@geophysical.com. or you can visit us on our website at www.geophysical.com. Thank you for watching.